Welcome to today's session of Advanced Computer Architecture. We are weaving, even discussing a paper related to the concept of parallel computers. We did the fundamentals. We discussed the generations of computers under this paper. Then we did some topics related to parallelism. That means elements of modern computers. Okay, so in the last session, we discussed the evolution of computer architecture. So first we'll review what we have covered so far, and then we'll take a new topic. I already told you, Flynn's classifications. Okay. So what we covered in the last session, we did the evolution of computer architecture. So under this topic, we discussed the types of computers based on the processing. Even in my beginning session, I told you computers are classified into several categories by using the process. Computers which are doing the process one by one, that means in a sequential manner, are called sequential computers. I said like that. Computers which are doing more than one process, that means program, at the same time are called as parallel. So by using the process, we can classify the computers. So our last session topic, evolution of computer architecture, discussed this. How computers are classified by using the architecture, and even how the computer architecture is evolved. How the computer architecture is evolved by means of process. So the architecture started with scalar. Thereafter, one by one, the concept of parallelism, parallel processing, was evolved. That means developed with the techniques like look ahead and pipelining that we have seen. Okay. There we have seen the today architecture. Under the evolution of computer architecture, there we have seen that today architecture of computer broadly involves two types of parallel computers, namely SIMD and the MIMD. So these are all the points that we have seen in the last session. Okay. So after weaving a glance, we have to take the next topic. What is that? Flynn's classification of computers. So under the Flynn's classification of computers, we are going to see, even discuss the architecture of four types of computers, namely SISD, SIMD, MIMD, and MASD. So I said the review of the last session, we did evolution of computer architecture. So under the evolution of computer architecture, there we have seen the evolution of computers based on the process. Computers started with scalar processing, and thereafter the concept of parallelism was developed, I said, with the techniques like that, look ahead, pipelining. Okay. And the today architecture of computer is having, even broadly having, two types of parallel computers, namely SIMD and MIMD computers, I said. So once again, we are going to see the diagram that we have shown on the last session. So after viewing a glance about the diagram, next we have to start the new topic. What is that? Flynn's classification of computers. From your examination point of view, the Flynn's classification of computer is a expected question. It's an assured question from the first unit. Even I'm regularly saying whether you are going to face a written examination, there you may expect the Flynn's classification under the 10 mark. Or the question might be asked as a split under 5 mark question, and even on 2 marks, you will expect the definitions, questions like that. Definitive questions like define SISD, what is SIMD computer, expand MIMD, so what is MISD. So such questions are definitely asked in your examination. Suppose by considering this situation, current situation, pandemic situation, in the end of this semester, probably on December or January, suppose you are going to face online examination, there you might expect question like this. SISD computer is expanded as expansion of SISD computer. SIMD computer contains, so like that. So if you are facing examination as an objective type, there you might expect these questions. Okay. So now we look at the diagram that we have discussed on the last session. So what about this diagram? I said, once again, I am reviewing to all, please carefully listen that information. So the evolution of computer started with the scalar computing or scalar processing. So what is the meaning? The architecture of computer was introduced with the sequential computer. That means computers processed the instruction one by one in a sequential fashion. So after the sequential processing, a new technique, what is that? Look ahead was introduced with the help of IE overlapping and functional parallelism. So the look ahead is the first parallel processing introduced in the architecture of computers, even in the history of computer hardware. Okay, so what about IE overlapping? How look ahead is implemented by using IE overlapping? By free fetching the instruction. By introducing overlapping among instruction fetch, decode, and execution phase. So the look ahead is initially implemented with the help of which one? IE overlapping. Thereafter, functional parallelism was introduced through the hardware implementation process. So what is the difference between IE overlapping and functional parallelism, sir? IE overlapping is a software process. Okay, parallelism as a look ahead process, parallelism was introduced as an IE overlapping technique with the help of which one? Software. The same look ahead is introduced with the help of hardware functionality by implementing which one? Functional parallelism. So what is functional parallelism? Implementing, even designing, fabricating multiple functional units as a circuit on the computer hardware. You just consider an example. A sequential computer is there which has to do addition, subtraction, multiplication, and division. In case the computer is doing sequential process, okay, in case the computer is doing sequential process, then all the set processes, addition, subtraction, multiplication, so these are all carried out one by one by using the same circuit. Automatic computer But under the functional parallelism, multiple functional units was introduced. Okay, so multiple functional units were introduced under the functional parallelism. So that multiple functional units could do addition, subtraction, multiplication, and division at the same time. For example, an adder is allotted for doing addition always. A subtractor is allotted for doing subtraction always. So like that, a multiplication is carried out. Actually, the multiplication process is carried out with the help of a circuit. So what is going on here? Multiple functional units are implementing different processes at the same time. So this one is the functional parallelism concept which implemented look ahead by means of hardware. So following the look ahead by means of high overlapping and functional parallelism, a famous technique I said in the last session, what is that? Pipelining was introduced. So what a pipelining is? Pipelining is a interleaved process, I already told you. Even an evolution of functional parallelism is pipelining. We can also say pipelining is an evolution of functional parallelism. So what about pipelining? Initially, pipelining concept was implemented as a software process called, what is that? Implicit vector. Thereafter, after certain cases, even after certain timing, the same pipelining concept was introduced as a hardware concept by the introduction of explicit vector. So whatever the case, either case, implicit or explicit, under the implicit or explicit process, instruction and data are processed in an interleaved fashion. So what is the meaning of interleaved? I said wait and execute fashion. Okay, so here the implicit vector is implemented as a software process. Explicit vector is implemented as a hardware process. So once again, the explicit vector was expanded by introducing memory to memory vector processing or register to register vector processing. The introduction of register to register vector processing, explicit vector processing, yields the generation of parallel computing process, what I said, SIMD and MIMD. So under SIMD, there are two types of SIMD parallel computers. What are all them? Associative processor and processor array. So like that, under MIMD, there are two types of parallel computing. What is that? Multi-computer and multiprocessor. So today, the computer architecture is doing, even implementing parallel processing with the help of massively parallel processors. Okay, so today parallel computers are doing billions of instruction, more than billions of instruction per second, more than billions of programs per second at the same time. So this one is the evolution of computer architecture that we have discussed in the last session. So here the evolution of computer is started from scalar, and now it contains parallel processing. So these are all the concepts we discussed. So here you have to consider one point, an important aspect. Here the computer architecture is evolved, even discussed by considering the process. How a computer, even a processor within a computer is doing the work, either sequentially, that is one by one, or at the same time. Okay. So it's the concept of this evolution, this tree-like structure, computer architecture structure. Next, we have to discuss a new topic which considered the computer architecture, even which classified the computer architecture based on the instruction and data. Mind it, again I am saying the current topic that we completed, evolution of computer architecture, arranged the computer architecture by means of processing as a general. Here, this concept didn't consider the instruction and the data as a separate one. It totally considered all these things as process. The concept that we are going to discuss as the next topic classified the computer architecture by grouping instructions and data. Okay, so what is that? That one is popularly known as, what is that? Client classification. So what about client classification? Who designed this? Who designed this concept? A computer engineer. A computer engineer, Michael Flynn. Okay, I have shown his photo on the screen. He is now working, still alive. He is working. Michael Flynn, okay, classified the computer architecture based on the processing of instruction and the data stream as a separate process. So you follow what I'm saying? The last topic classified the computer architecture by considering the whole thing as a process. But here the Michael Flyn's in short Flyn's classified the computer architecture based on the instruction and the data. So here he grouped, Michael Flyn's in short Flyn's grouped the computer architecture by grouping instruction and data separately. So when this could happen in 1972, okay. So what are all the classifications that Flyn's classified? SI, SD. So what is that, sir? Single instruction stream over single data stream. So from the names itself, you can easily identify what that architecture is doing. For example, here you take this SISD, single instruction stream over single data stream. Suppose a computer is following this architecture. I already told you, architecture is the arrangement of components within a computer. Suppose a computer is following SISD architecture, then that computer is doing single instruction over single data stream per time. At a time, the computer which follows SISD is doing single instruction over single datum. So that is what is called SISD. The next architecture, what is that, sir? SIMD, single instruction stream over multiple data stream. So what about this architecture? Here, single instruction is operated over different data, collection of data. Suppose a computer is implementing SIMD, then the computer uses a single instruction to operate multiple data. So this is what is called SIMD. Then MIMD, multiple instruction streams over multiple data streams. So what is the meaning of this? Suppose a computer is implementing this concept, multiple instruction stream over multiple data stream, then that computer can process multiple instructions over multiple data at the same time. So what is called that we are expecting parallel processing. Okay, so one more architecture is there. What is that? MISD, multiple instruction streams over single data stream. So it's the yet another architecture of computer classified by Flyn's, Michael Flyn's. So what it is doing? MISD operates single data stream with the help of multiple instruction. So what will vary here? You see the instruction and the data. Okay. So under this aspect, all the sequential computers that we are using are following which architecture? SISD. All the sequential computers that we are following for uses which one? SISD, single instruction stream over single data stream. Okay. All the vector computers, there is a classification of computer, vector computers. Actually, vector computer is also a parallel computer, one of the parallel computers. But there is a difference. Vector computers always executes same type of instruction or same type of data. As a vector computer always executes what is same type of instruction or same type of data. So such type of computers are following which one? SIMD. Sequential computers are following which one? SISD. Vector computers, special computers which executes same type of instruction or processes same type of data are following which one? SIMD. And importantly, parallel computers, that means the computers that we are expecting. So such parallel computers are exploited MIMD architecture, multiple instruction stream over multiple data stream. Okay, in practical, SISD computer is used for different purposes, different sequential processes, like that. SIMD, single instruction stream over multiple data streams. So that computers are exploited for special purposes. SIMD computers are exploited for special purposes. MIMD. So what about MIMD? MIMD computers are exploited for, that means utilized for general purposes. MISD, multiple instruction stream or single data stream. So that concept, that computers were, MISD is also having one more name. We will call that MISD, even we are calling the MISD as systolic arrays. There is another name, what? Systolic arrays. Later we'll discuss that. So the MISD is also known as systolic arrays. So systolic arrays are also utilized for some special purpose processes. So SISD is used for general purpose under sequential processing. MIMD is used for general purpose under parallel processing. SIMD and MISD, that computers, the computers which implementing this SIMD and MISD are following, actually doing special purposes, special purpose problems. They are exploited for special purpose problems. Okay. Next, we have to consider the level of parallelism. The level of parallelism attained. All these architecture, in these 3 or 4 architectures where the parallelism is attained, we have to consider. First, we'll take the SISD, single instruction stream over single data stream. So here, there is no multiple process. Always single instruction is executed over a single data. So here there is no parallel processing, you just leave that. Then you take the second one, SIMD, single instruction stream over multiple data stream. So what is that? In this architecture, parallelism is attained at data level, because here multiple data are processed, but a single instruction is executed. So under SIMD, parallel processing is carried out at data level. Parallelism is attained at data level. You will expect a question by considering this concept on your examination. Under SIMD, where parallelism is attained, at which level parallelism is attained? You have to simply answer, under SIMD, parallelism is attained at data level. Like that. Under MIMD, parallelism is attained at both instruction and data level. Because it's a MIMD, under this architecture, under this computer which are following MIMD architecture, multiple instructions over multiple data is processed at the same time. So here the parallelism is attained at both instruction and data level. Even MIMD exploits full level of parallelism, both at instruction and data level. Then the last one, MISD. Under the MISD architecture, you see, under the MISD architecture, parallelism is attained at instruction level and not at data level. Under MISD, parallelism is attained at instruction level and not at data level. So these are all the points, introductory points that you have to consider regarding this topic. Which one? Flying's classification. Okay. So now we have to take each architecture one by one. First we'll take which one? Single instruction stream over single data stream. Here, this one is the block diagram, architectural diagram of SISD architecture, single instruction stream over single data stream, even uniprocessor architecture. So what about this? You see on the diagram, there is a single control unit and a single processing unit and a memory unit. So here this architecture contains a single unique control unit and a single processing unit. Processing unit is nothing but CPU, central processing unit. Even it is nothing but a processor, microprocessor, and a memory unit. Okay, so under this architecture, even on the computers which are following this SISD architecture, both the instruction and the data are stored on the memory, and during the processing level and even the processing time, both the instruction and the data are fetched from memory unit and processed by the processing unit. So what is the meaning? Initially, instructions and the data are stored on memory, we know well, as in our sequential computer, because sequential computer is also following which architecture? SISD. So during the processing time, instruction is fetched from the memory as well as data is fetched from the memory. So both instruction and the data stream are fetched from memory unit and processed by the processing unit. So here the important point is this: at any time, single instruction is processed over single data. So here there is no parallelism. Okay, it's a sequential processing computer, even it's a scalar computer. As in our last topic, evolution of computer architecture, this SISD is put on the scalar type. It is nothing but SISD architecture is nothing but which architecture? Scalar, that we have seen on the last topic. So these are all the points that you have to consider. Okay, under the SISD, single instruction stream over single data stream. Here the important point is, what is that? There is no parallel processing. Then the next one, single instruction stream. You see, single instruction stream over multiple data stream. So what about this architecture, sir? You see, this architecture, it is somewhat new for you. We know the architecture of SISD because we are using that SISD computer, sequential computer. So we know well, within SISD, there is a single controlling unit, single processing unit, and there might be a memory. What is that? This is one kind of which one? Parallel computer, SIMD. So what about the architecture of SIMD? Under the SIMD architecture, there is a single control unit. Okay, there is a single control unit. And number of processing elements. In case of SISD, we said processing unit. Under the SIMD, even on SIMD, MIMD, and MISD, we have to call the processing unit as processing elements. So the SIMD architecture is having single control unit and multiple number of processing elements and a distributed memory. So under SIMD, there is a host computer. So all the remaining computers are sharing. The host is having a distributed memory, and all the remaining computers, processing elements, have to share that distributed memory. Even the arrangement is like that. Suppose there is a SIMD computer, and within that SIMD computer, There is a single control unit and a number of processing elements and a distributed memory. Provided each processing element is having a local memory of its own. You follow what I'm saying? Suppose there might be a SMD computer. It contains a single control unit, number of processing elements, and a centralized distributed memory along with a local memory per processing element. So what about the processor? Initially, the data, here the data is called as data set. So the data set were stored on distributed memory of host, that means the computer, and that data set were streamed from the host to the local memory of every processing element. You see the diagram? The data sets loaded from host, that concept, the word on the diagram shows that the memory, the distributed memory on the computer is storing all the data and instruction. Okay, so the distributed memory is having all the data sets. During the processing, all the needed data set were loaded on the local memory of each processing element. So initially, data set were streamed from host to the local memory of every processing element. Okay, as well as the control unit is receiving a single instruction from the host. You follow what I'm saying? The single control unit is receiving single instruction from the host and issuing that single instruction to all processing elements. Now the processing element, after receiving the single instruction from the control unit, the processing element started to process by using the data on the local memory. So it's the concept. So again, I am repeating the process. Please listen. Under the SIMD architecture, there is a single control unit and a number of processing elements along with local memories. Okay, so under the same architecture, there is a distributed memory. Okay, here the distributed memory refers the whole memory of the computer which implements SIMD. It is nothing but the main memory of the computer which implements SIMD. So apart from the distributed memory on the computer, each processing element is having its own local memory. So initially, before going to start the process, all the needed data set were loaded on the local memory of processing element. Okay, so thereafter, the single instruction is fetched from the distributed memory by the control unit. So after fetching the single instruction from the distributed memory, the control unit forwards that instruction to all processing elements. Each processing element is receiving the instruction, single instruction from the control unit, and each processing element started to execute the same instruction, single instruction over the data from the local memory. So what is going on? A single instruction is operated over multiple data stream. So what is called single instruction over multiple data stream. So these are all the concept. So here this SIMD is mainly exploited, utilized by the which company vector computers. Okay, so here under the so under this topic, in the today's session, we started to discuss Flynn's classification. Okay, and we explained and discussed how the Flynn classification is classified the computers. Flynn's classification classified the computer by considering the instruction and the data. We have seen there are 4 classification: SASD, SAMD, MIMD, and MASD. Okay, so now in this session we completed 2. So what are them? SASD and MASD. SASD is exploited by which one? Sequential computer, and the SAMD is utilized by vector computers. So these are all the points that we have seen. In the next session, we have to discuss the remaining 2 architectures, that is MIMD and the MASD. So we'll do that concept in the next session, even in one more session. Here I will wind up the today's session. Thank you, one and all. Bye.